Hello everyone, in today's video we'll be discussing on block diagram reduction technique. Here are the topics that we'll be discussing in today's video. Firstly, we'll discuss on the introduction, followed by importance of block diagram reduction, basic rules for block diagram reduction techniques, steps for block diagram reduction, numerical example, advantages, and finally the conclusion. Introduction. Block diagram reduction simplifies complex control systems by minimizing the number of blocks and connections. This method enhances the analysis and understanding of a system's behavior. Block diagram reduction is crucial for engineers and researchers in control systems. This technique is a fundamental tool for improving the efficiency of system design and analysis. Importance of block diagram reduction. Simplifies the representation of complex systems, enabling easier analysis and control system design, aids in identifying essential components and their interrelationships within a system, facilitates the application of control theory concepts to optimize system performance, enhances understanding and management of system dynamics for improved control solutions. Basic rules for block diagram reduction. The output of multiple blocks connected in parallel can be combined at a single summing point. The input to multiple blocks connected in series can be branched out to individual blocks at branch points. Feedback loops can be simplified using loop reduction techniques. Simplifying feedback loops enhances system stability. Block diagram reduction techniques. Cascade reduction involves merging blocks that are connected in series into a single simplified block to streamline the system. Parallel reduction simplifies the system by combining blocks that are connected in parallel into one equivalent block. Feedback reduction focuses on simplifying feedback loops within a system by employing specific loop reduction techniques. System simplification can be achieved through cascade reduction, parallel reduction, and feedback reduction by consolidating multiple blocks into a singular, more manageable units. Steps for block diagram reduction. Identifying components and connections. Start by thoroughly analyzing the block diagram to identify all key components and their interconnections, ensuring each element and its relationship are clearly understood. Apply reduction techniques. Utilize reduction techniques such as cascade reduction, parallel reduction, and feedback reduction systematically to simplify the block diagram, aiming to minimize the number of blocks and connections while preserving the system's functionality. Simplify the diagram sequentially. Apply the identified reduction techniques to the block diagram carefully, simplifying complex networks into simpler equivalent forms. Verify system consistency. After simplifying the block diagram, verify the reduced model by comparing its behavior with the original system to ensure that the essential dynamics and performance characteristics remains unchanged. Numerical example. So obtain the transfer function of the control system whose block diagram is as shown in figure. So the blocks G2 and G3 are in parallel. They can be combined into a single block with a gain of G2 minus G3. Now in step 2, the blocks G1 and G2 minus G3 are in cascade, so they can be combined to a single block with a gain of G1 of G2 minus G3. Now we are moving the summing point after the block H2. The resultant block diagram is as shown. Now the blocks G4 and H2 are in cascade, so they can be combined into a single block with a gain of G4 into H2. Also blocks H1 and H2 are in cascade. They can be combined into a single block with the gain of H1 into H2. Now interchanging the summing points, then further combining 1 and H4 into H2 into a block with gain of 1 plus G4 into H2 and simplifying the feedback arrangement into a single block, the resultant block diagram is as shown. Now, combining the two blocks in cascade into a single block, the resultant block diagram is 1 plus G4 into H2 into G1 of G2 minus G3 by 1 plus G1 of G2 minus G3 into H1 H2. So the transfer function is C S by R of S equal to G1 G2 minus G1 G3 plus G1 G2 G4 H2 minus G1 G3 G4 H2 by 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. Advantages: facilitates easier analysis and design of control systems, streamlining the engineering process, simplifies complex systems, enhancing understanding and enabling effective optimization, enables efficient implementation of control strategies, leading to improved system performance, streamlines the analysis, design, and implementation of control systems for optimal performance and understanding. Conclusion: block diagram reduction is a fundamental tool in control systems engineering for simplifying and analyzing complex systems. Understanding the basic rules, techniques, and algebraic operations is essential for effective block diagram reduction. Mastering block diagram reduction techniques enables engineers to streamline complex control systems, making them easier to manage and analyze. By mastering this technique, engineers can enhance the efficiency and performance of control systems in various applications. Thank you.